Last stage, we cracked the transformer open, one forward pass, attention as a soft dictionary lookup, multi-head, and the three shapes a transformer can take. Here is the part nobody tells you. Every famous model you have heard of, Llama, Mistral, Gemma, DeepSeek, Qwen, is the same machine as GPT-2 from 2019, same skeleton. The last 6 years are not 6 revolutions, they are a parts catalog. Start with the chassis. GPT-2 is a tall stack of identical blocks. Each block does two things: look around with attention, then think with a tiny neural net. Stack it deep, predict the next word. That design never changed. So when a model feels smarter, it is almost never a new skeleton. It is better parts, more data, and a lot more scale. Swap 1. How the model studies itself. GPT-2 used layer norm. Modern models use RMS norm. It throws away the mean centering and the bias, keeps only a scale. Same quality, fewer operations, and it trains more stably in very deep stacks. Boring reason, big payoff. Swap 2 is the clever one. Position. GPT-2 added a position number to each word. Modern models rotate the query and key vectors by an angle that grows with position. Rotation means attention only cares about the gap between two words, not where they sit. And there is one dial, the base frequency, that stretches the usable length. Turn it from 10,000 up to a million, and a model that handled 4,000 words now handles 100,000. The other three swaps fast. Attention used to give every query its own key and value. Now groups of queries share keys and values, which shrinks the memory the model carries during a conversation. The little neural net got a learned gate, a valve that decides how much passes through, and the bias knobs got deleted. 6 swaps total. Everyone is about stability, length, or cost, not magic. Let me show you the whole swap, one part at a time, on the actual block. Here is the GPT-2 block. Layer norm, learned positions, full multi-head attention, a plain gated free MLP, biases everywhere, a 50,000 word dictionary. Swap the norm. Layer norm becomes RMS norm. The Y caption, stability, fewer ops. Notice we did not touch anything else. The block is identical except this one box. Swap positions. Learned absolute becomes rope, applied right inside attention. The Y, relative, and it extrapolates to long context through the base frequency dial. Swap attention's memory. Full multi-head becomes grouped query. 8 key value heads feeding all the query heads. The Y, the curvy cache, shrinks 4 to 8 times. Hold that thought, it is the entire next episode. Swap the MLP. Plain glue becomes SWI-glue, 3 matrices, a learned gate, and delete the biases. The Y, more quality per parameter, fewer parameters, no measurable loss. Last swap. The dictionary grows from 50,000 to 128,000 and up, better at code and other languages, and there it is. The GPT-2 block has quietly become a Llama 3 block. Same chassis, 6 swapped parts, but I waved my hand at one of them, the KV cache shrinks. That single swap is the difference between a model you can afford to serve and one you cannot. Next, we put attention on the rack and climb the whole KV cache ladder. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.